Hi, everybody, and welcome to your lesson about force. So first, what is a force? Well, a force is either a push or a pull that happens on an object, and a force can cause a change in motion. So it can either stop motion from happening, or it can change an object's speed, or it could change an object's direction. And there are different kinds of forces that can cause this change in motion. So we've got, of course, a contact force. And then we've got the force of gravity. You guys all know this one. And then we've also have the force of friction. Now, I've got a toy car here, so I'm going to model with that. But as the car is like rolling along, the force of friction happens between the wheels or the tires of the car and the ground. And as the car goes one way, the force of friction goes the opposite direction. Okay, now when we determine the net force, which is essentially how much force is happening total on an object, we can do one of a couple things. We either need to add the forces together or we need to subtract the forces from one another, and I'll explain that more now. If we have two people that are trying to move a box, and the person here that would be in blue is pushing on the box in this direction with a force of 15 newtons. And like maybe let's say that there's a smaller person that's trying to help out as much as they can, and they're able to apply 5 newtons of force in that same direction on the box. As they work together, that's our key word, together, they're going to move this box with a force of 20 newtons. Remember, if you're working together, together is our key word that triggers our minds to add, right? So they're going to be working together to move that box to the right with a force of 20 newtons. But what if these people are working in opposite directions, you might say? Well, then we have to subtract the forces from one another. So if this guy is over here pushing to the left with a force of 16, but this guy matches his strength and can push also with a force of 16 to the right, those would be subtracted from one another. So 16 newtons minus 16 newtons is zero net force. So this object would not be able to go to one direction or another because the net force is 0. That means that they're stuck in one place. No side is winning over the other side because there's a net force of 0. Okay, so if the skateboard is sitting still, what do you think about these net forces? Hopefully, if it's sitting still, you remember that the net force must be 0. It's not able to move. Net forces will cause a change in motion. It's either going to speed up to one direction or it's going to stop going in this direction and start going in the other direction. It's going to change somehow. So if there's no change in motion, the net force is 0. What if the motion is not changing? If motion is not changing and the car is traveling at a constant speed, right, then the forces must be balanced. If there's no change in motion, no net force, then it's also balanced. There's nothing pushing on it from one way or another. So if it's sitting still, it's in balance. So if we're talking about balanced forces, we know an object is balanced if it's either keeping a constant speed, meaning not accelerating, not decelerating, or if it's sitting still and its net force is 0. Balanced, okay? So more about balanced forces. Remember, if there's no change in motion, the net force is 0. So if the gravity is pulling a book down and the table is having a force on that book as well, pushing it up, and that book is just sitting on the table still, it is a balanced force. Okay, unbalanced forces happen when someone starts trying to push on that book. So if the hand applies a 30 newtons of force on the book, it'll push it right off the table. Okay, let's say that for some reason the table is not able to apply enough force back onto the book to withstand the force of gravity pulling it down. That table would buckle and we would have an unbalanced force. Okay, so that is what we have for today, you guys. If you have any questions, please reach out and I'll be happy to answer your questions. I'll see you soon.